So now I would like to welcome Andrew on the stage. Hello, Andrew.
Hello. Hello.
Very fine. Everything seems to be working.
Yeah.
Good to have you on the stage. The stage is yours.
Thank you very much. Hey, that's not my first slide. That's one of my middle slides. One moment. Let me stop sharing and start sharing again, just to make sure we've got the right things going on. There we go. Welcome. Hello everyone. Sorry about that technical hiccup. My talk today is about integrating Silverstripe with Elastic App Search. And I know you've all heard something along these lines before, whether it be, could you make it a bit like Facebook? Could you make it a bit like Instagram? Could you make it a bit like Google? This is a line that actually came out from the client while I was working on this with them. Now, that's a bit of clickbait. Really, they said that because they wanted the UI to look kind of the same, but it does make a really good title. So I thought I'd throw it on there for you. First up, who am I? Why am I qualified to talk about this? So I'm Andrew Paxley. Up until earlier this year, I was known as Andrew Aitken Fincham. There's a little history behind that, but if you've seen that Aitken Fincham name, that was actually me, same person. I joined Silverstripe in 2015 as a junior developer. I worked on the support desk, resetting people's passwords and all that kind of stuff. So if you've had your password reset, there's a chance I had something to do with it. After about a year there, I flew over to the UK to work in the London office with Dan Hensby. And then there was a period, the dark times, where I didn't work for Silverstripe. And then there was even darker times when COVID hit, and we were locked in our flat in the middle of London, not having the best time, looking back at what we should do. Should we return to New Zealand? Looked like a good idea. And then I thought, what could I do when I get back to New Zealand? And it turned out Silverstripe were hiring. And so we put two and two together. And now I'm back in the fold as principal developer on the application support team. So if you've ever raised a ticket and it's been a code fix, that's my team. And that's the team I'm responsible for. You may find me as Andrew Andante on GitHub, or if you're in the Silverstripe users Slack, I go by Andante. A very distinctive avatar, I think, although there are a few other Commander Keens about, so don't get me confused with them. And I can sometimes offer some useful advice. So today, what I'm going to talk about is basically what was the problem that we were trying to solve with Elasticsearch, how Elastic and Silverstripe Limited combine, how Elastic and the Silverstripe framework combine, and then what are the next steps. So what was the problem? The problem was, for the client, the search was no good. Basically, people would type in things into the search bar that they thought would get them useful results, and it wouldn't. Or people would type into the search bar a particular code that matched a particular document, and it wouldn't find it. Or people would type in something that was very, very small, or contained something that had a little bit of weird punctuation in it, and it wouldn't be found. And they'd spent some time investigating how to fix these things using Solr, which was the default search engine that comes with Silverstripe, and that the full text search module is set up to work with. And they found it a struggle. They found it really hard to get a hold on what they were looking at because the devs had to do all the work and they couldn't get a handle on the changes that they wanted to make. And the turnaround time was really slow with that. Additionally, they had some problems with doing facets correctly. They had some problems with sort of relevance logic where they thought that something should come out on the top of their list and it ended up coming out somewhere near the bottom. And that's basically they had a really bad experience using Solr out of the box. And so we decided, we proposed to them Elasticsearch as an alternative. So basically, the main problem was that they would always look for a document with a very specific code, something like, DOC-123, and it would never come up in their search results. And so that was a big problem. So the solution was Elastic App Search. Ta-da! So what do you have to do to make Elastic App Search work? And these are the steps you'll need to take. First, you need to index the site content. This is very similar to Solver. Second, you need to search that content. Again, very similar to Solver. And then profit. It's pretty much that simple. I mean, most search engines and things work the same way. You need to tell the engine what you want to store, and then you need to look into all that and get your results back. And that's how you make the search experience better. Also, with this project, they wanted to add autocomplete. They wanted to add some styling. It had to work with Subsites and some other little bits and pieces. So what's the first step? Step 0, setting up your infrastructure. In Elastic, these are called engines. You may know them more like indexes if you're familiar with the Solr setup, and other search engines have sort of like different ways of referring to the same thing, but it's basically the big block of data where all the information lives. And now Silverstripe Limited is an Elastic partner, so we have our own infrastructure set up that we can build up in Elastic Cloud, and so we set that all up for them, and it means that now we've done our homework, we know what we're doing, we have a couple of people in our agency who are Elastic masters, and we could take that forward. And it looks a little something like this. The name's obscured, but this is the back end of the search engine in Elastic App Search. And one of the most exciting things about Elastic App Search, and one of the selling points for the client, was that you can see a lot of things in this back end that you can't see, that are sort of invisible with Solr, where you have to go into that very strange Solr admin UI, which isn't the most appealing thing, particularly to non-technical people. So here you can see a really high-level overview of how many people have been searching on this engine in the last 7 days, how many queries, how many operations, and you can see a whole list of recent API events. There are also lots of other tabs down this left-hand side that you can go in and influence. So synonyms are managed in this dashboard. Curations and relevance tuning, they're all managed in the dashboard by the client. So they get full control over how the results are returned, rather than having to ask a dev to make a change, make that change, let it sit for a couple of weeks and see how it plays, and then realize that that's not what they want to do, and then ask the dev to make another change, and then keep iterating over that. It's a really slow feedback loop, whereas this one is really fast. Additionally, you have a document management display here, where it shows you all of the fields that have been indexed and their values. You can do some sorting and filtering down this left-hand side. And there's also a query tester. So you can make all the adjustments and tweaks that you want with your synonyms, with your curations, your relevance, and all that kind of thing. And then you can run a query in this dashboard and see how that affects the output. My favorite one is to do with the relevance tuning and the curations. What you can do is, even though a particular document might not, according to all your relevance settings, come out the top of the list, if you know that that's what people are looking for, you can just manually drag that to the top of the list. And so if someone is searching for 8 convention and finding that there are no results, you can put the profile for Andrew Paxley right at the top of that list, because you know that that's actually what they're looking for. You may have some sort of selfish investment in that feature. So once you've got your engine set up, what's next? You need to add some fuel. So this is where the first of our modules comes in, first piece of code. So this is an open source module. It's called the Silverstripe Search Service, and by default it's set up to work with Elastic. The idea is that in future we'll expand to work with other search engines, but Elastic was the one that we were obviously working on, and so this is the one that comes by default built in with the game. So what you need to do is you need to define your indexes. In Solr you traditionally do this in PHP. But in Elastic, this is all YAML based. And it's nothing too complicated, but basically here you define your index here. This one's called content, and you tell it which classes to include. So here I've got a page class, and I've got a DMS document class. And in this page class, you tell it what fields to index. There's a couple of sort of little helpers, so you can do title true. And that's just the most straightforward one. It says, yes, I want the title, and I wanted to get the title property. Other ones you can do a little fancier. So here I have elemental area, but actually the property I want is I'm passing in a method name, get elements for search. And so I know that it will call get elements for search on any page that it indexes, and it will return that blob of data and save that into elemental area. And there are other things you can do as well. For example, subsite ID down here, you can see the options type text. I'm storing that as a text rather than as a number for a reason that I can't quite remember, but I'm pretty sure there was some sort of type clash mismanagement somewhere that really got on my nerves. You can also store these as arrays. So you can see here taxonomy terms is terms.id. So this terms is a relationship. So the page has many taxonomy terms, and it just stores all of the IDs of those taxonomy terms as an array against the item. Then you run a configure. So again, very similar to Solr configure, but this is called search configure or configure search, something like that. It's a dev task. It behaves very similarly. It pushes the schema out, pushes it into the engine, and then you can see all of these things are pushed up here. Now, there's a couple of things that weren't in that list that get pushed up by default. These are things like source class name and source ID, those kinds of things, and sort of actual class name as well. So if you have a home page that extends a page, it will store home page and it will store page, because page is the reason it got indexed. But you might need to know that it is a home page, and it will store all those things, and then it will store the ID of the data object as well, so you can get it back once you return the results. Then you need to run a full reindex. This will feel familiar to a lot of people who have worked with Solr as well. But this one, yes, essentially you just run a job in the admin, very, very similar, loops over all the things that fulfill the criteria, in this case pages and documents, and pushes all that data out to the engines. My experience, this has been a lot faster than a Solr reindex. I'm talking sort of, it was 15 minutes to do, how many documents were there in there? 30,000 documents, I think, which is very, very fast compared to what I'd seen on Solr. So that's a big plus if you're looking for a speed improvement there. And then I had to make a few little tweaks based on the default configuration in the module. So the first thing I had to do was I had to add the extension to DMS document, which is a model. Obviously, the extension by default is on just page, I think, possibly just site tree, one of the two. I should double check that. But I also added the search service extension that you can see here to DMS model document. The second thing I had to do was to reindex pages when elements on those pages are published. Now, I had a problem where people working on the site, the content authors, were updating the elements on their page, the content blocks, saving those content blocks, and then expecting that updated content to show in their search results, and it wasn't. And so one of the things that is still in progress on the Silverstripe search service module is getting all of that inheritance and things all up in line. So to work around that for the short term, I put in a very simple extension, which basically says if you have a page and that page has search service extension, then you call this parent add to indexes method, and it takes care of it all for you. I used an environment variable for the index variant. This is so that you can, usually you would use this, it would just take the environment. So if your Silverstripe environment type is dev, it just prepends dev to your engine. And this is so you can use the same config, but push it to different engines depending on your environment. So you don't have to have a elastic config UAT, elastic config prod, elastic config dev, elastic config Andrew. That's just annoying. So you can just define this app search engine prefix value, and then that will sort that all out for you. And the last part I did was I turned off the HTML crawler. So you can see here that's this configuration value down the bottom, crawl page content equals false. So you can have it behave in a really similar way to a lot of other crawlers, where it just will hit the page, render all the HTML content, and then store that in Elastic. I was having problems with that. It was starting to store little bits of JS, and it was spending a lot of time loading each page, because it essentially uses direct to test to try and load the page and then store that in Elastic. That was taking a long time for me, and it wasn't as useful because I also found that a lot of duplicated pieces of information would end up on every page. And so in the end, just narrowed it down to the fields and things on pages that I actually needed. And then the last part was I added this thing, concept of a content type. Now this was a sort of meta category that wasn't actually stored on the data object anywhere. And this is totally on documents, well, essentially on documents, and then also on site tree. And so the reason for that was that in the search results, the client wanted to be able to filter by pages, documents, or files, depending on what the user was actually looking for. And so you can't see that because it's all the way off the top of the screen, but there is a list of document extensions and a list of file extensions. So document extensions are things like .doc, .pdf, and file extensions are sort of JPEGs or whatever else, CSVs, that kind of thing. And so we can set this meta variable content type, and then that also just gets pushed into Elastic as a field, but not one that is directly associated with a database field on the object. So the next part is to go and find the things out of the engine. This one uses another module, but unfortunately this is a bespoke module. It's called Silverstripe Elastic App Search module, and that's an in-house one. So one of the first things I had to do, that took a wee bit of figuring out, was I had to realize that I needed to prepare the query to send it to Elastic. It's not quite as simple as just trimming the query string and returning that. I had to do a little bit of magic. Now this looks horrible, and it is a bit horrible, but there's some important things going on in here. So Elastic will take Lucene operators when it's doing the search, if you put them in. So basically, the assumption I went with was, if you're putting in an uppercase and, an uppercase or an uppercase not, or you're using the double quotes, then we assume you know what you're doing. We assume you've done that on purpose because you're trying to do some fancy search, and so we'll just let you do it. Excuse me. But then we also had some problems with these stop words. Now, stop words, if you don't know what those are, they're basically words that are ignored. So Elastic is basically saying, if you put the word as in your search term, I'm not going to look for the word as, because as is going to be on 90% of pages. Same with the, and there, and then, and all of these other ones that are in this list. The problem is that if you require a stop word, then the search breaks, because it's also ignoring those words. So if you require a word that it's ignoring, you get no results every time. So I had to do a little bit of not requiring those words. Additionally, the client wanted to do an and search rather than an or search. So the more words you put in, the less results you should get, not the more results you should get, which is why I'm adding these prefixes, the plus and the minus prefixes. Because it behaves like a standard Lucene search, if you do plus the word, then it must include that word. And so I ended up manipulating these strings to must include every word that they added in order to make it more words reduce the results rather than increase. And then there's some fancy preg matching down the bottom to ensure that there's at least a letter or a number in the word as after I've split it out, because otherwise, yes, it gets very annoyed about searching for nothing. All of that eventually got to the point where the queries were returning what we were expecting them to do. Additionally, you add result fields. Now, these are essentially saying, like, bring me back these results. You can query along whatever you like. So, for example, if I wanted to query file content, I can do that, but I don't necessarily have to return file content from Elastic when I return that result. I could just return just the ID or something like that if that's what I wanted to do. In these cases, we're returning title, summary, elemental area, and this type snippet size 200 means that it's coming back with 200 characters. And if it's a snippet, then it gives you that highlighted section of where it has matched. So if I'm searching for the word Andrew and I find the word Andrew in the title, it'll come back in italics, not bold. That was another Jira ticket. You can add facets as well. So in this particular one, we wanted to be able to facet by taxonomy terms and by content type, which is that field that I was manually adding in. And you can do a few pieces of configuration in here. You can sort them. You can say how many of these things you'd like to return. And you can do that in a separate query. So all I'm doing in this query is searching for everything in the index, and then just getting these facets back. That's all I want from those. Adding these facets is at the moment, it's a little weird. You have to use standard classes and objects and things like that. But the goal is to one day make that a little bit more Silverstripey than it currently is. True to form, you can add filters. These look kind of the same with these standard classes. But we have, if you have a topic filter or a type filter used by those facets, it passes it straight into the query URL. And then we can pass that in to filter all. Filter all means you have an any or an all option. So an all is, it must have all of these criteria, or an any is it must fulfill any of these criteria. And finally, a piece that got added really late in the project was the idea of multi-search. So this was to get around a problem where initially when I was searching for the facets and searching the query, a filtered query at the same time, it would only return me the facets of the results that after they'd been filtered. When actually I wanted the facets of everything so that I could so that the user could change them even if there were currently no results in there. So the way to do that would normally be to make two queries and work with both of those sets of results, but Elastic lets you fire multiple queries at once. So you can bundle them into this multi-search query class, add multiple queries, and then you just return the results as an array like that. Additionally, there's a separate document library search, which is more advanced, and there's a couple of extra things to add on to that one. So again, we're looking at filters. This one in particular was a date filter. You can use really simple, straightforward DB date time create, and it likes it in RFC 3339 format. I don't remember what that format is, but I was very happy we have a method for it. And then, so that's a from date, and then the to date, along the same lines, except I had to add 86,399 seconds to make sure that it was just before midnight on that day, because dates are always hard, and then you'd have things that were published in the time, and it was just a nightmare. But we figured that out. It also was a sort on the document library, so by default it was sorted by publication date descending, but there was also a sort toggle that you could do up and down. Hello cattail. And being able to fire that in, it was pretty straightforward as well. You just need to pass in the type of sort and which direction you want it to go. And finally, rendering it all in the template. It's very similar to the way that you would render anything else, but you can use this elastic snippets variable in your template, and you just have dot and then the lowercase version of your field. The reason it comes through like that is that is how Elastic stores it. You can try and do some mapping you can do some mapping once you've got the results back, but this is the most straightforward way to do it, is to just turn it elastic snippets dot title or elastic snippets dot summary, and then it will give you that HTML that you requested. The final was going to be the final piece of the puzzle was sending the autocomplete through a proxy. This is also a module, Silverstripe Elastic Proxy. Sort of. It's more of an internal module that we have where there are two ways to go about achieving the same thing. One is to have a raw PHP file just in the public directory, which is what I ended up doing. The other was a proper Silverstripe controller. And the reason for that is that you need to be able to boot the Silverstripe environment to get some environment variables out of there, because that's how you're going to be able to connect to Elastic. So the reason we wanted to do this is that we built a React-based search header on the main, the home page and the main header of the site. And the client wanted query suggestions when they were typing. So, if you type TES, it says, do you think test might be a really good thing to search for? And you can say, yes, please, and go off and find that. And that needs to be done in real time. Now, if you're doing that through React, through JavaScript, the traditional way would be to pass through your credentials in order to query the Elastic engine through there. But we didn't want to do that. We didn't want to expose those credentials. because then if someone with evil intentions decided they wanted to slam our Elasticsearch instance, then they could hijack that request, and then they could make a lot of requests. Now, the actual security implications of that are relatively small, because this should, in theory, all be public information anyway. The main thing you'd be worrying about is a DDoS. But if they can get the credentials, then they don't have to DDoS the actual site. They can just DDoS the Elasticsearch instance, which could cause problems, especially if you're sharing hosting. So what we do here is we pass through, you can see dummy values, and we have this endpoint base, which is the _search proxy. And again, search key dummy value and the engine name dummy value. And then once it goes off to the proxy, it comes back with the information, and then it passes it into this React component, which renders the suggestions and has a nice little grayed out, very Google UI looking thing where you can use arrow keys up and down and select it and pass that suggested query off to the actual search form to make the search. So importantly, you need to put in a proper htaccess redirect here, because you don't want it to hit Silverstripe. If you're going to exactly _search proxy, you want to pass it to to the search proxy PHP. And the search proxy PHP works like this. Essentially, we boot Silverstripe environment, or we auto-load the Silverstripe environment, and we go and get your credentials, the endpoint and the search key, and make sure that they're valid. Then we have a sanity checklist of endpoints that we're allowing you to hit. So here, the only one we wanted the users to be able to hit is query suggestion. We don't actually want them to be able to look at any documents or post any documents or anything like that. The only thing this is used for is query suggestion. Now, you don't have to only use this for query suggestion. You could actually build the entire thing, the entire search thing as a React app, and then you could expand this a little bit. But for the purposes of this site, query suggestion was the only thing we needed. So we do a little bit of an explode here, because basically we are pretending that we're the Elastic endpoint. So the request on key up, key down, one of those two things, will fire the request through to search proxy instead of Elastic. So we're saying, instead of taking it to query suggestion, pass it through. Sometimes it puts .json on the end. I could never quite figure out when it did that and when it didn't do that. I think it depends on your environment. So if .json is there, we scrub it off just so we can check the endpoint. And then if it's not in the list, then we just block it there with a 403. And then we take the engine name that we got out of the environment, and we take the action that we've popped off the end of the initial post request, and then we hard code it in. And then we make the request that way. So that way we don't expose your environment credentials as part of the request. You sort of do it in the back end and then pass that request back up to the React app. So it shouldn't be sniffable. And then Subsites. It was bound to come up. It had all been going rather too smoothly up until this point. And then Subsites came along and made things extra exciting. So what was the problem with Subsites? You might have seen earlier in the schema that the idea was to filter by subsite ID. So when I was initially indexing all the content, one of the fields that I would index was subsite ID. And it made perfect sense that when you were querying querying the engine for content, when you were on subsite 1, to only return results from subsite 1. When you're on subsite 2, only return results from subsite 2. It made perfect sense, and it all was well, except the query suggestion endpoint doesn't take filters. And what that means is that whenever you were being auto-completed suggestions on any given header, what would happen is that it would give you suggestions from all of the content in all of the subsites. And so you would be typing TES, and it would say, it would bring you up a suggestion for test this thing from my main subsite. And then you would say, that seems like a good suggestion. You'd scroll down, hit test things from my main subsite, and you would get no results, despite it being the top suggested query. And obviously that's not good. I think I spent half a day with my head in my hand like that, thinking, oh dear, what have I done? The solution was pretty inelegant, but it was very effective. Let's make more copies. So we had to reject the config, rework the module. essentially what we did is we split it out so we have one engine per subsite. And this is something that may have to be replicated if you're doing something along the lines of Fluent or anything else that is a reason to divide the content up, perhaps like public and private content. You just use more engines. So I added an ability to designate a subsite ID on an index. So this is, instead of a content index, it's a subsite 0. And instead of a subsite content index subsite 1, although subsite 1 and subsite ID 4, that's going to cause problems. Who peer reviewed that? Probably me. And you can just specify your subset ID here. And then basically when you're trying to index a page or a document, it will loop over the indexes that are defined in the YAML, and it will see whether it qualifies to be indexed for that index. Index for the engine. So it will first say, am I a page? Yes, I'm a page. And then it will say, am I in subsite ID 0? And if it's not, it will skip it. And it will do that for each index that it qualifies for. I also learned, this is not directly related to Elastic, but this is a lovely piece of YAML syntax if you've ever seen it. So you can specify, if you look at this piece of config down the side, you have this and page defaults tag here. And then you can reference that right here, and that duplicates the YAML config. So you don't have to copy paste the same 50 lines all over the place. You can just do this, and it will mean all of that is copy pasted into there. And it was beautiful. And thanks very much, Ingo, for showing me that. So the last part was hooking that into the core module. So that's now being merged and it's in there. And it should be, as I said, relatively easy to replicate for Fluent when the time comes to do Fluent things. So with that, step 5, we profit, right? That's what we do. We go next. Did it work? Well, yes, it has worked. We've fixed all the bugs in their Jira backlog that specified what all the problems were with all the tiny things, particularly 2 and 3 character searches, or character searches where it was sort of like 2 letters, 2 characters, piece of punctuation, 3 characters, piece of punctuation, 2 characters. It used to blow up. Now it does not blow up. We managed to switch very easily to AND searches instead of OR searches. I say easily, it was all of that sort of syntactical magic, but it was relatively easy to do. We had all the filtering fixes that were having problems where if you were filtering by one taxonomy term, it would sort of override the others or they would clash, but now that's behaving in the way they would expect. And most importantly, the customer now has access to the dashboard so they can adjust the weighting of fields. They can say the title is very, very important and the file content not so much. And they can do what I was talking about, where you manually reorder the results as they come in. And most importantly, for them, they have improved visibility about the status of their indexes. So I ended up adding a CMS admin section. It's pretty basic, and design is not my strong point, but I think I did okay. I can hear some of you cringing, but this is what it looks like now. You have a link straight off to the dashboard from within the CMS. You have a link off to the Elastic documentation from the CMS. And you can see here, you can match your index names against how many documents the database thinks are indexed, how many documents Elastic thinks is indexed. And you can trigger a reindex from within the CMS as well if you need to. And if you're feeling very bold, you can click the big red button and click through the confirmation prompt and reindex everything if you ever want to. And the client was also keen to have a status update. So they don't necessarily have to be able to see the queue jobs, but there's just a little counter here that says, you know, there are currently 3 jobs in process. There are currently 3 that are broken, so they can keep tabs on actually how their reindexing and their publishing is going. So now what next? Currently, this is on UAT, so I can't even point you to the site. But it's being tested. The last few little kinks are being ironed out, and unfortunately it wasn't able to be released on time because of COVID and content freezes and things like that. But the plan is to get it live soon, quote unquote soon. One of the things they wanted for release was a built-in Solr/Elastic toggle. So I built a quick thing in the site config where they can toggle between Solr and Elastic, and they can do that for each of their subsites. So the plan is to release it and then not turn it on immediately, so they can run some reindexes in the background without actually switching the search over. And then gradually, one by one, switch the subsites over, switch the main site over, and then hopefully, no one will notice, or they'll just sort of like have that pleasant feeling of a good search experience wash over them and not really realize why they feel better than they did the last time they used the search. Then the plan is for the client to be able to do on-the-fly adjustments. If they're finding that people are searching for some particular search terms and still not getting what they want because it's buried down, they can push those up, and same things with tweaking the weightings of the fields like titles and all that kind of thing. And then I'm supposed to run some training and write some documentation, which I assure you I have definitely done. What's next for the search modules? Well, we would like some shiny new features. Spell check is something that Elastic has built in, but we don't have lined up quite yet with the modules. Now, this may not be true as of quite recently. I think that we have either a prototype version or possibly a working version of spell check now in our bespoke module, but it's something that we need to run out and put into a production site. There's also analytics tracking, so you can say like you can check which links have actually been clicked on. You can fire those events into Elastic and you can track that. So you can say, for everyone who searched for shiny, did they click on this particular GIF? And if people keep clicking on it, even though it's 4th or 5th down the list, maybe that's one that you want to bump up to the top. We want to improve the admin in the CMS, add a few more things, add a few more features, make it a bit better looking, and make sure that it works for non-Elastic search things. We want to sort of work out how dependency tracking is going to operate. Don't want to have to put an extension on every page to reindex it if the element's been published. I guess it's the other way around. Extension on the element to reindex the page. And just sort of work that out a little bit better so that you can reindex dependent objects as well. And then Fluent. This is a thing that is a very important part of the Silverstripe ecosystem. It's not something I had to work with for this particular site, but I think that the work that went into Subsites is really going to help. The idea of splitting the same content out into multiple engines should work relatively straightforward. And Elastic also lets you set the language of a given engine. So you could have a Spanish engine, you could have a German or a Dutch engine or whatever you might have there. And you can, in theory, relatively easily add a subsite ID and then a Fluent locale to your engine, and then it would perform the same sort of check that it's doing with subsite. Am I a page? Am I on the right subsite? Am I in the right locale? And then push it up like that. Already found a bug with translations that shows you how Fluent will come and influence you even if you don't have to work on it. There was a problem with splitting out file content. Now, one of the limitations of Elastic is that there is a limit to the post size that you can push into Elastic. And so what we did with giant files was we basically kept cutting them in half and then taking that content until it was small enough to fit. So the problem with that is if they are non-standard characters, and I'm sure I can see all of you people who have to work in non-standard character sets already know what's about to happen, is that you end up chopping it in the middle of a character, and then when it gets JSON encoded to fire off to Elastic, it doesn't like it one bit, and it throws an error, and everyone's sad. So changing that to MB substring fixed that a lot. Hat tip to Michael Kleiner for pointing me in the direction of MB substring instead of whatever nonsense I was doing to make this happen. So finally, a few shout outs. These people helped me a lot along the way getting this over the line. We have Matt Peel, Aaron Carlino, Stephen Macrogiani, Chris Penny, and Ingo Shoma. You guys rock. You helped me an awful lot. You merged all my pull requests. You listened to me talk absolute nonsense about things that I didn't really know what I was talking about. And we got there. We delivered a really good result for the client. We delivered a really good result for Silverstripe. And there are many more that have started to pick it up based on the work that we all did. So hat tip to you all. And thanks very much. That's basically all I have to say. Thank you for listening to me talk about Elastic. Thanks to the organizers of Stripecon for having me. And I'm not sure if I have time for questions, but maybe I do.
Thank you very much, Andrew. we always have time for questions. I think the question from Herbert was already answered.
Right, Subsites and Fluent. Yes, I believe it could. So my expectation is that we would be able to do Fluent in the same way that we did with Subsites, and therefore it should all work together. Obviously, I haven't tried yet, but I think it should be pretty straightforward to do.
We have another question from Johannes.
Sure.
We'll show it on the screen.
Is App Search and Management UI and dashboards above Elastic? I currently run a vanilla Elasticsearch. Would you recommend switching to Elastic App Search? Right. Yes. Essentially, it is. It's like it's like sugar on top of Elastic. So it does operate on Elastic under the hood, and we have had to occasionally sort of query the underlying Elastic instance to make it do things that you can't do by default with Elastic App Search. I think one of those things, for example, was spell check. I think we had to do some sort of sneaky underlying queries in order to get that. But Elastic App Search is really good for people who, for clients who want to take the responsibility of managing the index themselves, rather than leaving it up to the dev. Like if the developers are intending to still have all of the control, then you might as well just go with Elastic if you're the one making those decisions. But the beauty of the App Search dashboards and those interfaces is that they're really easy to understand for non-developers. Well, really easy. With a little walkthrough, then they make a lot of sense, and they can get some really quick and easy feedback. So like marketing people will be can easily go into that dashboard and say, like, we've had a lot of queries for Willy Wonka recently. Why is that? And so it's a lot more passable from that point of view than a Solr-based admin, or even sort of the Elastic or Kibana style things that are very divvy, if that makes sense. So they're they're different use cases, but ultimately it's all powered by Elastic under the hood.
Yeah. Thank you very much. I think you're available on Slack if there are other questions. And
yes, absolutely. I'll be around.
For now, thank you very much, Andrew.
Thanks, Andy.
See you on Slack.